So here we are with section 2.4. And like I had said prior to looking at this, once we have a handle on looking at the calculations that are done using the tangent ratio, the sine ratio and the cosine ratio, the calculations, the steps in the calculations are exactly the same, with the exception that, well, you're going to use the sine button if the question is involving sine, or you're going to use the cosine button if the question is involving cosine. But the biggest key to remember is that we need to remember what our trig ratios are. So you'll see that whenever I do these questions, I always write down SOHCAHTOA. It's my quick little acronym that tells me the definition of the three trig ratios. You know, although you're given them to you on your data sheet, and well, I have them right here in the notes, but it's always something I do. It's just a habit I'm into. Okay, so remember that SOHCAHTOA, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. That's how that acronym works. And here we have the definitions written out for you. And then of course you also have to remember that it all depends on what angle we're talking about in the question. So here's our triangle. It gets labeled in reference to the angle that's noted here, this black angle here. Okay? The hypotenuse is always opposite to the 90-degree angle. It's always the longest side of the triangle. Did I say opposite? I meant hypotenuse. Can't remember what I said there. Okay. Here, this side is the opposite side. It's opposite to the angle that we're talking about. It's the opposite side. And this would be the adjacent side. It's beside the angle we're talking about. Now, of course, I'll switch colors here because I can. If we're talking about this angle, well, then our labels are going to change. The hypotenuse still remains the same. It doesn't change. But this side would be opposite because it's opposite to the angle that we're talking about. This side would be the adjacent because it is beside the angle that we're talking about. Okay, so something to remember. Let's hit the examples. Example 1. Determine the sine and cosine of an angle. In triangle GHI, identify the side opposite to angle G and the side adjacent to angle G. So our first step over here, which side is opposite to angle G and which side is adjacent to angle G. So if this is the angle we're talking about, this is my hypotenuse. It's always opposite to the right angle in the triangle. It's the longest side of the triangle. This side is opposite to angle G. This side is adjacent to angle G. In triangle GHI, identify the side opposite to angle G and the side adjacent. Done. Determine sine G and cosine G to the nearest hundredth. Now, remember, if you see this type of question, it's just asking you for the ratio, not the angle. So we want the funky decimal number. Okay? So if I think about my acronym, SOHCAHTOA, if I think about my acronym, SOHCAHTOA, if I'm looking for sine of G, that's opposite over hypotenuse. Sine of an angle theta is equal to opposite over hypotenuse, and I will always write down that formula. I look at my triangle over here. This side is the opposite side. 17 is my hypotenuse, so I can go sine, I can go sine of, in this case G, is equal to opposite, which is 8, over my hypotenuse, which is 17. And if I calculate that out to 2 decimal places like it says, it's 0.47. Now remember, in calculating or using this later, you're not going to use 2 decimal places. You're going to use whatever number the calculator gives you, all those decimal funky numbers. Okay, there's the sine. Cosine, oh, you know what, I'll change colors for you. Cosine of an angle, back to my acronym. Where's my acronym right here? Is adjacent over hypotenuse. So I go adjacent over hypotenuse. Cosine of G, still using G as my reference angle, is my adjacent side, which is 15, over my hypotenuse, which is 17. Didn't change. The hypotenuse stays the same. 15 over 17. Calculate that out. 0.88 to the nearest hundredth. Okay. So there's example 1. Remember, example 1 is just looking for the ratio. The next step, and if you remember what we did before, the next step to find the angle, which I'll do again in a different color here, if I want to find the angle for angle G, I go, well, I've got sine of g, sine of an angle is equal to this ratio. So if I'm looking for the angle, I think to myself, well, I have to do the inverse function of sine minus 1, of whatever that decimal number was. And in this case, it came from 8 divided by 17. Okay. Which I don't have my calculator with me here. So, oh, I've got my phone calculator, which I really don't like using. So let's see what I got here. I want the inverse function of, my screen locks on, here we go. So yeah, that's why I don't like using these calculators, because I can't get my calculator to spin. Oh, there we go. Inverse function of 8 divided by, clear, 8 divided by 17, and I want the inverse function of second function sine, inverse function of sine of that. I got 28.07248 whatever, or 28 degrees. Now, theoretically, I should be able to take that same idea from here, and if I'm looking for the angle, angle G is equal to the inverse cosine of that number, 15 divided by 17. That'll give me, let's go, 15 divided by 17 equals second function cosine. Oh, look at that, 28.07248, or 28 degrees. Okay. Now that's the next step. Remember, that's the next step. What they wanted for this question was just the ratios, sine and cosine. So just these answers. Okay. So there's example 1. Be right back with example 2. I think it's example 2. Yep.